Again, a little bit further along in the project. I've got that little PCF8574 chip, if you can see down there in almost the center. It's wired in with VCC on the top pin, top left pin. Pin 1 is actually one of the address pins, and pin 0, 1, and 2 are actually the address pins, or however you want to number them. The bottom right is the ground for the IC. If you look at the top, there's a green and a, hopefully it's showing up as orange, pin coming in. I'll just point them out. I can get my little pointer down in there. We have a green, oops, we have a green and an orange coming all the way up and over into the I2C pins on your Nano. Now, I had to use I2C port scanning sketch that came from the Arduino playground to just confirm I had the address set properly. Pulling all 3 of this chip's address pins to the ground makes them, I think it came up as a hex 20, and then I just used its first 3 output pins, or its first 3 I/O pins, and ran them into an RGB LED that you see flashing in the background here. That's just some foam on top of an RGB LED and some current limiting resistors there. That's really all there is to it. I mean, you could simply solder those 3 pins however you wanted to this pin, and it'd be a very, very small footprint depending on what you're building. But just for this case here, I wanted to hook it up and test the output of the pins. There's a library, and I do forget the name of the fellow right now, but I'll put it in the link below. There's a library on the Arduino playground that bundles this up as a class, and it provides some nice functions. Like, I'm actually just doing the flip right now. I'm having it go from pin 0 to pin 2, so 1, 2, 3 pins, and it's just going, looping through those pins in a for loop, and it's actually using the flip state, so it flips it on and off, and it holds a millisecond on either side. And I'll probably put a link to that up on CodePad or such in a minute once I get that done. But really, all I did was a tiny edit to the sample code that was in the Arduino playground. But that part's working, so those chips are really easy to use. The next trick will be to get the infrared module that we had out earlier today. Next trick will be to get this little fellow. I don't know if that's going to focus in there. That fellow to work if we can. It would be only too easy to link the out pin of that into one of the spare pins on this, and that would be read in using the same library. The library has a pretty nice wrapped up class for you can write to the chip. You can write all its pins at once, just passing an integer that has all the pins in whatever state you need them, or you can actually do the equivalent of a digital write or digital read on each pin. So far as I know, you don't have to set this to input or output. You can just read it, but I'm gonna have to look and see that fellow's implementation. I haven't done the input side of this yet, but that's the status so far with this. Once I get it all set up working from Arduino, I will then move it over to a setup that'll work with the ESP8266 modules, and move on from there. And hopefully that won't take too long. Again, thanks for watching.